All right, welcome to Instant Understanding, where you're going to get faster learning, immersive comprehension, quicker remembering, dynamic thinking, and way more. We are in the section called Your Brain Processing Information. This is where the rubber meets the road. You're going to learn everything, or a lot of what you need to know about what actually happens in order for you to get information into your big noggin and for you to experience and understand it. So we're going to talk about the brain senses, the concrete senses and the abstract senses. We're going to talk about how you actually get information into the brain, the different models of the world, not the actual models of the world, but that your brain creates models of the world. And we're going to understand just a little bit about how that all plays into understanding happen in the parietal brain or parietal brain lobe, rather. So these are the four lobes of your brain. So we have the frontal lobe, the cerebellum, the temporal lobes, cerebrum, occipital lobe, and parietal lobe. I didn't make this slide. This is medical news today, but parietal lobe is actually what we love right now. So that's great. So this is actually your frontal lobe. Your cerebrum is all of this stuff, all four of your lobes of your brain and the cerebellum down here. This processes motor control and sensory information. So like when you move, temporal lobe, this does with, like language and you know what? We got to, so language and stuff like that. Your frontal lobe is about thinking and about what you're going to do in the future, different situations and scenarios. Your parietal lobe is about the abstract notions of movement, like how your body moves and so forth. But the cerebellum is like more the execution aspect, and then the sensory and control aspect. And the occipital lobe is, when you have your eyes, they're like around here. All the information goes in the middle of the brain all the way, and hence the occipital lobe, and that's where you process visual information. All right. So we got a different slide with a little more specificity about what happens. We have speech here, smell, hearing, and facial recognition in different areas. So you see your brain is has a lot of regions because a lot of stuff needs to happen. This is like not even the half of it. You have stuff where your body is represented, all types of things. But instead, we don't want to get lost in figuring out what exactly everything does in the brain, right? So we're going to take a step back and just focus on some high level general things. But if you wanted to know the different things that your brain does and where they kind of happen in your brain, there's a great graphic. All right. So what we want to talk about is this is your brain or reality, right? So in science, we talk about space, time, and energy. And that's great. And scientifically, we'll have, power and force and mass acceleration and those things. And what they do is they measure things on the point by point basis. So within a particular time span, there is an amount of energy. But sensorially, your brain doesn't think in terms of energy. Your brain thinks of movement. So your brain doesn't say, "Oh, I have this much energy. It's I can move this much." Is what I'm saying. I mean, I don't know if there's any scientist that ever gonna instantly saying, "Oh yeah," or maybe everybody in the brain's gonna be like, "Yeah, that makes sense." But what happens is space, we see visual. So, you look around and instantly you see the spatial relationships going on. Time. So when you hear a car going by and the music gets louder and louder, as well as the pitch changes before it passes you, after it passes you, what that does is, you hear things. So when you hear things in the world, your brain maps what you hear onto space. So you don't just hear things, you hear things from directions. And that's why your ear is shaped the way it is. It creates reverberations so that your brain can understand, oh, okay, well, I hear it a lot, so it's probably in front of me. So then when you turn your head, you now know like if the sound is coming towards you and hits your earlobes and then it goes into your ear. or that little, it hits the nub of your little ear, and then it goes into your ear canal. Well, that's a little bit of the physics of it. And then kinesthetically, what you feel is also in your parietal. So, your your motor senses, your where your proprioception, where your limbs are on your body when you stretch them, when you ball your fist up, when you point a finger, when you wiggle your toes. All of these things are both the movement as well as the spatial relationship between that and something else. So if somebody rubs your knee, you know it's your knee, right? So those are the physical perception, and then that's kind of mapped onto the spatial, temporal, and motor. I'm gonna just call that the abstract mental experience. Like you have a Cartesian, three-dimensional Cartesian grid on which you walk around the world, and all of your experience is mapped onto that. So that's your brain on reality. All right. And then there's a learning methodology. His guy's named Pavio, and he calls what he likes to emphasize dual coding, which is you need to be able to experience something in order to learning in two channels: first words and pictures. So a couple of chapters ago, I was telling you how Dr. Seuss was the greatest of all time. And it's not just because of the words, it's also because right next to the words, he showed a visual picture of what it is that you experience. And that's the words and pictures, right? So those are the things that happen outside of your brain or body. That's the multimedia presentation, or what I like to call the world. And then once it starts hitting your body, you have your senses. So your ears and your eyes. So we have eyes and ears, right? And I guess if you're turning the page, there's a little bit of kinesthetic stuff there, but I don't think that the texture of the page is going to be on the test, right? So once your eyes and ears get them, we then experience them as sound and images, right? And then, like, oh, okay, what did you read 20 seconds ago? That's your working memory, right? And so the sounds then get processed by your language centers, and your images get processed by your occipital lobe, and then those then get integrated into a specific experience, moment by moment. As you read the words, and in your peripheral vision, you see the cat standing on the ball with a rake and a cake. That's your experience. So moment to moment, you keep reading, and then what you do is you integrate it, and that's how you get information into your brain, right? And then because you already knew the words, your prior knowledge then helps you interpret what that is. If you see a new word and you don't know what it is, and you're like, oh, what's a rake? Somebody might point to the long red stick, or you might know every other word. So you look at all of the other things that the cat is juggling, and you're like, oh, okay, so I don't know what this is, but what that word is, and I know all the other words. And the only thing he didn't mention was this thing. It might be the cake or the fish in the bowl. You say, oh, okay, that's what that is. So you pick up the context clues from the image that you see. And that's why children's books and graphic novels are so important, because you get the visual information that makes the words make sense, right? Cool. Now, in computers kind of do something kind of the same thing. So you have typing and you have your mouse movements, and then what happens is it goes into the central processing unit along the bus, and then that then gets mapped onto, okay, well, this particular, like let's say this mouse is, 100 pixels by 100 pixels away from the top left. If you click on the right, if you do a right click, this pops up. All of the activities that here we go. All the activities that happens then gets translated into a graph into your GPU, which then turns on particular lights around the screen. This is actually kind of funny, because what we have is a hologram inside of a movie on a display. So I like a little bit of MC Escher in my life. So that's kind of the same thing that happens with your brains, with Pavio's dual coding. Your computer's doing the same thing. That point where we're talking about the active processing and the integrating, Well, that is what happens on the display. So then you make some actions and you type some more words, or you click it somewhere else and it changes what happens on the display, right? Okay, cool. So now we're going to enhance this a little bit. So the paths of brain-based understanding. So we have the world, like we talked about, the words and images on the pages, right? And then we have the eyes and the ears. I'm going to include the body, and that goes into the images, sounds, and feelings. So we have that going to the occipital lobe, the temporal lobe, and the feelings are the intero and proprioception, right? And then we start integrating that along space, time, and motion. Boom. And then what we have is the experience that we have. Just wanted to connect back to the graphic before. So that's your integrated experience. And then when you do stuff, you actually, you make motions. So that what happens is you change your body, right? So you change your feelings, and you have your afferent nerves that push, your efferent nerves that change your body position, and you have your afferent nerves that receive the information about where your body limbs are. Don't worry, we'll put this into context a little bit. So, and then once you have your experience, then you can think about it. So you experience the world, and then the other parts of your brain can say, oh, this is this. Oh, that is that. So you have models. So, if you turn your head and you look at an object, your brain's like, oh, that's what that is. If you turn your head the other way, you see a different set of things, and your brain will be like, okay, that's that far from me. And if you're like, oh, okay, well, what is that? I'm looking at bananas and oranges. So I have a concept of what a banana is. I can think about the banana tree. I can think about the roots of a banana tree, where it grows. I can think about oranges, gets turned into orange juice, but I've never had banana juice. Things like that. You can start thinking more about individual things or things that you don't even sense. So, and in this, I just wanted to break that out into what you have, about things, how to do things, and what they are. So, I know a banana is because somebody told me what a banana is, right? Of course. But then I can think conceptually about a banana, like, okay, well, I can peel it. It is part of the plant family. It is it houses a seed, and as fruit houses seeds, they're rich in sugar, so that when the plant starts growing, it has a source of energy that it can eat from. So, falls on the ground, and there might not be a lot of energy around the ground. So what the plant does is it creates all these sugars. So then when it starts to grow roots and then grow limbs, or not limbs, tree limbs, if it's going to be limbs, stalks and leaves, what happens is there's a source of energy there that the seed can then draw upon when it's eating, so that it can, it has like a little starter kit for life, right? Cool. Now, okay, bet. So we have the models of the world, where you have the, what I'm going to call like the physics of things. So, if you throw a ball, it's going to bounce. Or if you throw a ball and it's deflated, it's just going to plop on the ground, right? So what happens is you have the physical world, and then you have your mental models of what's going on. And that's your subjective personal knowledge, right? And then you have the conceptual world. So if I'm looking at this banana, you don't see the banana. But when I talk about the banana growing and the seed and stuff, both of us have probably heard something about that. So we have the objective scientific model that is the conceptual models. And then there's a lot of interaction between these things. So we have between mental models and conceptual models. So this, and I didn't make this diagram either. So I'm just to let you know, I'm on the one hand, it's because I'm lazy. Just kidding. And on the other hand, it's because I wanted people to know that I'm drawing upon a lot of different bodies of knowledge in order to integrate them and present them to you, right? So we have understanding is when you have a conceptual model tell you how the mental model works. You have perception and action. So the perception is your afferent nerves and your action is efferent nerves. And if you ever wanted to figure out like what the difference between afferent and afferent nerves are sensories. So when information comes through, like if you rub your hand together or you ball your fist, all of the nerves that go from your hand into your spinal cord into your brain. It goes, from the outside in. That's afferent. So it's, when people talk about art, they're talking about things having affect, AFFECT. But when you do things, you're effective at it. So you have efferent nerves that go from your central brain out to your limbs. So the action is effective, and the perception is affective. So we have efferent nerves and perceptive nerves and efferent nerves, right? And then when you relate your conceptual models to the world, these are not necessarily specific. These are the nerves going through your body, and these are inside your brain about the mental models. It's kind of hard to show everything realistically. So, you interpret stuff and you represent stuff. Great. So, but I don't want to harp on this. Cool. So then also, you have mental models, but you also interact with the world with perception and action. So you have your mental model of the world, and then you say, okay, well, I want to do this. So maybe you want to read more about the story, and you think, okay, well, what do I think is going to happen next? Maybe you want to go to a store, and then you think about the different stores you have to go to. Maybe you have to buy something, right? Where are you going to buy it? What stores have it? So what you do is you create mental simulations about the different ways you could accomplish your intention or goal. And then eventually you go act, right? You use your afferent nerves to get in the car, drive, take your wallet, find the thing, take your wallet out, pay. That's the world. And the closer you get to achieving that intention or goal, the less of these loops you have to go through. And so you say, okay, well, I'm not there. Are we there yet? So we try to compare what our current experience to the mental simulation about how we achieve our goal. So this is kind of like just a really simple feedback loop about what's going on. I just wanted to show the interaction of the mental model in your world without it being a one-way street like this, right? So this is kind of like the world, and I'm just talking about understanding and how information gets into your brain, and we make it a little more interactive by talking about the feed forward and feedback in the big loop of learning, acting, and updating your mental models. Oh, so the updating your mental models. So what will happen is you might compare it, and you might say, oh, I'm closer to your goal. Or you might get into a situation where you're like, this store doesn't sell that type of things. So then that you add to your mental model of how things work. So the next time, or how things are. And so the next time you go to that store, you're like, oh, I'm not going to be able to get this. So you have to plan for a different store. So over time and lots of experience, you just learn a whole lot more, right? And you create a whole lot of mental models about what types of stores carry things and how often they're in stock, how often they're not in stock, etc., etc. All right. So also, if we just want to look right in the middle of the brain, we can talk about, the mechanical, the linguistic, the conceptual, the experience and memory, and the visual. And we talk about these things in general, but I just wanted to throw some labels on what area of the brain happens. There are things happening. So experience and memory, that's in your cerebellum, right? You think about things and conceptually, and you break them apart into categories, mental representations. Like, even this right here, it's a conceptual diagram with words, that's on a screen. So all of these things are kind of happening, and at least I am, you're moving your eyes around, and that's the mechanical aspect. So all of these things happen at the same time, and we know things when we start coordinating all of them happening at the same time. So it's not just, oh, I just learned something. It's not just, oh, you have a body of words or concepts, which may or may not use words. Like you can have, physical concepts when you're talking about in physics and chemistry. You talk about atoms like molybdenum and selenium and hydrogen and their interactions, but the words themselves and the labels don't run the model or the mechanics of what they do. So you also have inert gases, and you have stuff going on with organic chemistry, which is carbon based. you have metals. These are all conceptual distinctions between types of things that are based on the mechanical aspect, right? So that was us. You have the conceptual things based on how things actually interact, right? So it's all coming together now, all right? And so I just want to talk about cool. So this chapter is just trying to teach you about the paradigm shift to understanding, right? So in learning methodologies, they're talking a lot about how that person gets information, the audio visual, right? So I'm going a step further and saying once it's audio visual, that's great. And once it's in your brain, you may even have pictures in your brain. But what's really happening is your mental models are functional. So there's a spatial motor component. And that's where most of your understanding happens. It's not just that you see something, it's the reality that what you see represents. And that is a spatial motor construct. So it's not just linguistic and conceptual, like what you know and what you know about. It's a lot the mechanical, the know-how. Nobody's ever seen a molecule of hydrogen. We've seen pictures of models of hydrogen. We've seen drawings of models of hydrogen, but we've never actually seen hydrogen. It's just too small, but we know about it. We know what it does. We know what it interacts with. We know it doesn't interact with. We know its chemical weight. We know how many electrons it usually has. We know how many protons and neutrons it usually has. So these are the things that we understand, linguistic and conceptually, but those are, know what and about of what it actually is and how it works and interacts in the world. And the other thing I want to talk about real quick is when people start talking about knowing things, they talk about, adding to your body of information, where I think of more integrating into it. So, it's not just like putting another book on the shelf. So if I learn more about a car, it's not just like I have a piece of car and I put it somewhere else and, it's just around there. Like I have to open the car up, you got to take the transmission out and put it back in. So what you're doing is you're actually integrating the new information into the old information, if you're doing it right. We'll get into that a little later. Cool. So my strong thesis is what happens in your brain, just, because we kind of did a survey of all of the things about the information getting to your brain, that understanding happens in the parietal lobe and that understanding is mechanical. So in the next chapter, what we're going to do is we're going to talk a little bit more about how that works and how that works in your brain and how it works as you learn things, and how we can make sure that when you're learning something, it's not just the linguistic or the conceptual. You have representations in your brain that show you how things happen over time, and how you can get a little more explicit about that, even when the information that you're presented doesn't show it specifically mechanically. Like you might get something, if you're in a political economics class, you're going to be hit with a lot of concepts, but you're going to have to turn those concepts into motor constructs in order to understand the difference between the things, because it's not all just about classification systems. Those classification systems, whether you're talking about socialism or capitalism or Georgism, what happens is those talk about relationships between people, governments, and whatnot, and you have to have different examples of them. And it's the different examples that you can then theorize about and classify that differentiate between the two things or three things. So cool. So we went through that. It was fun and fantastic. So we talked about the senses, the concrete and the abstract, where we have the concrete senses of I'm about to say your eyes, ears, and body, but the sensory, yep. And then we have, the visual, oral or audio, and feelings, and space-time and motion, right? We have how you get information into the brain, and similar to how computers display information in the computer. We talked a little bit about models of the world and how understanding works in the parietal brain. So until next time, this is Byron Woodson from Instant Understanding, where you get faster learning, immersive comprehension, quicker memory, dynamic thinking, and a whole lot more.